Like, how much of a fear is it of micrometeors or any of the possibilities? What can you do to mitigate that?
Uh, I think actually, I mean, space is very empty. Like once you get out of Earth orbit, space is like kind of unnervingly empty. It's just like when we send spacecraft to Mars, it's not like, oh, we lost a spacecraft because it got hit by a micrometeorite. That's not been the cause of any trips to Mars. Like no trips to Mars have failed because of micrometeorites. Now, a Dragon spacecraft, which operates in low Earth orbit, does have micrometeorite shields. It has shielding. And micrometeorite shielding it's different from normal shielding because like you get hit by something that's moving at like you could have a relative velocity of like maybe 30 or 40,000 miles per hour. Yeah, so very very fast. Or just thought of another way, call it 10 to 20 times the velocity of a bullet from an assault rifle.
And what are you using?
Like, yeah, so well, it's interesting. You actually, in order for micrometeorite protection, if you have anything that's solid, it will just push that chunk of solid stuff right through. So if you had like a solid plate of aluminum or steel, the micrometeorite would go right through it. So what you actually need to do is have a gap. So you have an initial like hard surface, a hard metal surface that the micrometeorite hits. It then atomizes into a conical spray, like an atomic spray. So it's important to have that gap so that the micrometeorite can hit something, hit the first layer, atomize after hitting the first layer, then it turns into an atomic, like a cone of atoms that then embed themselves in the second layer. You need like maybe a couple inches of gap.
Wow.
Yeah, that's how micrometeorite shielding works.